Greetings, Panthers. It is Dr. Augustine again. This is part 2 of a 2-part video on limiting reactants, and we're going to take a look at a more complicated problem than the first problem that we looked at. Okay, let's take a look at this problem. This one looks pretty terrifying. Sodium hydroxide reacts with carbon dioxide to form sodium carbonate in water. If we start with 15.2 grams of sodium hydroxide and 25.6 grams of carbon dioxide, what is the limiting reagent? That's one thing we're looking for. What is the excess reagent? In other words, identify which one's which. If 14.7 grams of sodium carbonate is formed, what is the theoretical yield? And what is the percent yield? I haven't defined percent yield yet, but I will in a second. And then this last part is actually the hardest part. How many moles of excess reagent remains? All right, so if you look at this problem, this looks a little bit intimidating. Okay, we got a lot of information in it, but let's break this down step by step. First step is to figure out what are the reactants and what are the products. And what I'm going to encourage you to do when you're watching this video is, I'll tell you where we want to go, and then why don't you see if you can do that. So first thing we want to do is identify the reactants and the products, and we want to write down a balanced equation. Okay, so sodium hydroxide, NaOH, reacts with carbon dioxide, CO2, to form sodium carbonate. Na is a plus, carbonate CO3, 2 minus, so we got to bring that 2 down here, plus water. All right, now we need to balance this equation. I have 2 sodiums here, so I'm going to need a 2 over here. And we got 1 carbon, 1 carbon. And if you look, we have 1, 2, 3, 4 oxygens on this side, and 3 plus 1 is 4 oxygens on this side. 2 hydrogens on this side. So this equation's balanced. All right, first step, you always need a balanced equation in order to do either a limiting reagent problem or a stoichiometry problem without a limiting reagent. So very first step, balance the equation. Now, looking at the problem, we say if we start with 15 grams of sodium hydroxide and 25.6 grams of carbon dioxide, what is the limiting reagent? So I'm just going to write these above here, 25.6 grams of this and 15.2 grams of sodium hydroxide. So this is a grams to moles type problem. We saw a couple of these before. Remember, we've got now mass of reactant going to mass of product. That's the type of problem that we have. Okay, so I'm going to give you a second. Why don't you stop the video now, and you're going to need to calculate molecular weights of everything. We are trying to find the theoretical yield and percent yield of sodium carbonate. So this is actually what we're trying to find, sodium carbonate. All right, so why don't you stop the video and calculate some molar masses, and we'll go from there. Okay, so the problem we're looking at is we're trying to find which one's the limiting reagent, which one's the excess reagent, trying to identify them. So we're going to use my technique to do this. And again, if you want to do it the other way, that's fine. I'm going to write the equation mole ratio and the experimental mole ratio. Experimental means from the information up here in this problem. Equation means from the balanced equation. Notice we have 2 moles of sodium hydroxide, 1 mole of CO2. I'm going to put the one with 1 on the bottom because I don't need to use my calculator for that. So I'm going to put 2 moles NaOH for every 1 mole CO2. And that's equal to 2, obviously, the mole ratio. And the experimental mole ratio, I need to convert these masses into moles. So I'm going to start with 15.2 grams of sodium hydroxide. And I need to multiply that by the molar mass, which is 1 mole NaOH for every 40 grams. NaOH, those cancel each other, and we have 0.380 moles NaOH. Okay, so in my experimental mole ratio, I need to put that one on top, 0.380 moles NaOH. Divided by, now I need to figure out how many moles of carbon dioxide I have. 25.6 grams CO2 times 1 mole CO2 for every 44.01 grams CO2. That cancels that, and that is going to give me 0.582 moles CO2. So that's going to go on the bottom, 0.582 moles CO2. If I take that ratio, that is equal to 0.65. Okay? What does that mean? Well, 0.2 moles over 1 gives me 2. This is 0.65. 0.65 is less than 2. That tells me I do not have enough of this. I need a lot more of this to get me to 2. In fact, it would be 2 times more than this is what I need. So something like 1.1 or something. All right? So therefore, this is the limiting reagent, the sodium hydroxide, and the carbon dioxide is the excess reagent. Why is that important? Because we need to use the limiting reagent to calculate my products. Remember, if I have 10 slices of bread, 15 slices of cheese, it's the bread that determines how many sandwiches I can make. So the limiting reagent is the one that allows you to figure out how much product you can actually form. Okay, that's why you have to do that first step. If the problem is not worded, this is a key point here, guys. If the problem does not tell you one of them is in excess or you have a stoichiometric ratio or something, you have to assume it's a limiting reagent problem. This problem does not give me any indication which one I have enough of and which one I don't have enough of. All I have is the masses. So if all you have is the masses, then you have to assume it's a limiting reagent problem, and you have to start by finding the limiting reagent. In this case, sodium hydroxide is my limiting reagent. So let's keep going then. If 14.7 grams of sodium carbonate is formed, what is the theoretical yield? What is the percent yield? So the theoretical yield means how much sodium carbonate can I form if I start with 0.380 moles of sodium hydroxide, or actually 15.2 grams of sodium hydroxide. All right, so the first thing we're going to find is how much of that sodium carbonate can we actually form. So I'm going to say grams Na2CO2 is equal to 0.380 moles NaOH. We already found how many moles there were, so I don't need to recalculate that, times 1 mole Na2CO3 for every 2 moles NaOH. Where does that come from? It comes from the balanced equation, times, now I need to use the molar mass of sodium carbonate, which is 105.99 grams Na2CO3 for every 1 mole Na2CO3. That guy's going to cancel that guy, and that will equal to 20.1 grams Na2CO3. All right, let's check to make sure my sig figs are correct. Here's my answer. I have 3 sig figs in this answer, 3 sig figs here, 3 sig figs here. So my answer should have 3 significant figures. So this guy right here, this is called the theoretical yield. All right, so you might be asking yourself, what the heck is this number, this 14.7 grams? It says if 14.7 grams of sodium carbonate is formed, what's that number? That number is actually called the actual yield. If in your problem it tells you so many grams are formed, are produced, yield, I mean, those are the key words you're looking for. 14.7 grams of sodium carbonate is formed, is produced, yields. That's called the actual yield. So we can use the actual yield then to find the percent yield. All right, and the way we do that is quite simple. The percent yield is equal to the actual yield divided by the theoretical yield times 100%. All right, so we're going to look up here for the actual yield, 14.7 grams divided by 20.1 grams times 100%. And if we do that calculation, that comes out to 73.1%. That would be called the percent yield. All right, so if we look back up here in this problem, we have found the limiting reagent, check. We found the excess reagent, check. We have found the theoretical yield, check. We found the percent yield. All right, so this big, intimidating looking problem, we're now working our way through, and we're almost finished with it, but we have left ourselves the worst part of this problem. How many moles of excess reagent remain? And I'm going to use an analogy to help you figure this out. We're going to go back to our bread and cheese example. Okay? So, recall in our bread and cheese example, we have 10 slices of bread plus 17 slices of cheese yields, remember this is in a 2-to-1 ratio, so yields 5 sandwiches. How much cheese do we have left? That's what this problem is really asking. How many moles of excess reagent remains? So, in order to find the number of cheese, you say, well, let's see. 10 slices of bread makes 5 sandwiches. That would mean I would use 5 slices of cheese. So I must have 12 slices of cheese remaining. Correct? How do we figure that out? We started from the limiting reagent. We figured out how much of the excess reagent got used, which is 5 slices of cheese, based on the balanced equation, right? It's 2 slices of cheese or bread for every 1 slice of cheese. So they're in a 2-to-1 ratio. That's how we find out how much cheese gets used. Let me say that again. We start with the limiting reagent, same thing as if we're counting the theoretical yield, but now we're going to find out how much of the excess will get used, again based on the stoichiometric ratio, and then we're going to subtract the amount we started with from the amount that got used. Let's put this in a little more tangible terms. So you can think of it this way. The amount remaining is equal to the amount total, or maybe starting amount, if you want to call it that way, minus the amount used, and that will give you the amount remaining. And by the way, this can be either in moles or in grams. Say that again. Amount remaining, what our problem is asking, is equal to the total amount, the starting amount, minus the amount that got used, and I can do this in either moles or grams. All right, so if we look at our problem we started with, we're trying to find out how many moles of excess remain. Let's start by thinking about what is the excess. Okay, the excess we said was carbon dioxide, so CO2 remaining is what we're trying to find, moles of CO2 remaining, right? How many moles of excess reagent remain? So from the problem and from my equation down here, the amount remaining is equal to the amount starting, or amount total, minus amount used. Okay, so how do we find this? Amount start will be given in the problem, and that is this, that's this guy right here. It's kind of small, I've shrunk it down. It's my 25.6 grams of CO2 times 1 mole CO2 for every 44.01 grams CO2 equals to 0.582 moles CO2. Okay, that's my starting amount. Now I want to find out how much got used, and this is the key conceptual idea. A lot of students get lost on this one, so follow me here. So the number of moles of CO2 used are equal to, we start with the limiting reagent, just like my 10 slices of bread. I'm going to start with 0.380 moles NaOH. And now I'm going to use the balanced equation, the mole ratio from the balanced equation, which is 1 mole CO2 for every 2 moles NaOH. In other words, every 2 moles of NaOH gets used up, 1 mole of CO2 gets used up. And that is going to equal to 0.190 moles CO2. That is the amount that got used. Okay? I used up 0.38 moles of sodium hydroxide, and that also used up 0.19 moles of CO2. So my amount remaining is equal to 0.582 moles minus 0.190 moles, or 0.392 moles CO2 remain. All right, that's the most difficult part of this problem, but if you can fight your way through that, and I think you'll understand everything there is to know about theoretical yield, percent yield, and how many moles of excess reagent remaining.